All right, we're going to focus on lesson 9 today, and the title is Representing, Naming, and Evaluating Functions. The book has a pretty long outcome, but they want you to understand that a function from one set, meaning like we see these pictures over here of these animals. This can be considered one set, and the actual words represent another set. So the function is a function from one set called domain, so this might be the domain, to another set called the range, assigns each element of the domain to exactly one element of the range. So we cannot have the elephant be called a zebra as well. There's only one specific element in one set that relates to one specific element in the other set. Okay, and this is a more compact definition of a function. Function is a unique relationship between where each input, meaning one from this range or domain, has a single output, meaning the range. Okay, we already talked about this, that the input relates to domain, meaning the x, and the output, f of x. So this will be x, and this is the range, f of x, or y, if we relate to our y-axis. Okay. Okay, so let's look at our opening exercise. It says match each picture with to the correct word by drawing an arrow from one word to the picture. Okay, this may seem very pre-K-ish, but we have this picture, and that is the polar bear. So even with a simple exercise like this, we can begin building this concept of function, okay, where there must be a set of inputs, the pictures, let's call that domain, or the x values, and they can be paired with a set of outputs, or the range, according to some criteria. Okay, so below this we have the actual definition of function. Function is correspondence between two sets, x and y, in which each element of x is matched to one and only one, okay, this is important, element of y. The set x is called the domain of the function, so make sure you underline that. So the whole thing about all this wording here is that you have an input, which is our domain, which is our x, and f of x, which is our range. So one element from the domain has a unique relationship with one element in the range. Okay, but please make sure you read this in, and if you have questions, you need to let me know. So it will make more sense when we go to the first example. So example 1 says define the opening exercise using function notation. So the function, when we say function notation, we're talking about this function f. Okay, so f is defined as the set of animals pictured. Okay, and then we do the arrow for our notation, and we have to define the second set, or the y, which are the words listed up there. So words listed. So we remember we have two sets, one that has the animals pictured, and the other set that has the word listed. So we have to assign each animal to its proper name. Okay, so the domain, we have to also say the domain and the range. The domain in this case are the 4 animals pictures. And the range is the words elephant, camel, polar bear, and zebra. Okay, so what we just did in example 1 is we used function notation to describe an opening exercise, and we also define the right domain and the range. So let's go to example 2 now. All right, so let's take a look at example 3 together. Okay, so we have the first, the domain X. So one set has 1, 2, 3, 4, and the second set has 5, 6, 7, 8, 9. Okay, so notice that we have 4 elements in the first set and 1, 2, 3, 4, 5 elements in the second set. Okay, so they're not the same, they don't have the same amount of elements. So let's say function f says pick one element from the first set that relates to one element from the second set. So I have 1 and 7, so I take 1 and 7, then 2 and 5, 2 and 5, good, 3 and 6, and 4 and 7. So what I noticed that 7 shows up twice. Okay, one time with 1 and 7, and then the other one with 4 and 7. So is f a function? If yes, what is the domain and what is the range? If no, explain why f is not a function. So in this case, f is a function, so say yes, is a function because each element of the domain is matched to exactly one element of the range. Okay, so the domain is 1, 2, 3, and 4, and then the range would be 5, 6, and 7. So looking at function g up here, I have 1 and 5. So I have 1 from the x and 5 from the y. Then 2 and 6, that one's okay. 1. Now I realized that I have 1 and 8, so 1 is paired both to 5 and 8, which makes g not a function. Okay. Because so it's not a function because an element of the domain is assigned to more than one element of the range. Okay, so because if g is not a function, we're not going to have a domain or a range. So then what is the f of 2? So since f is a function, we can actually find the f of 2, which is 5. Since 2 is matched to 5. So if f of x, the next one is f of x is 7, what might x be? So if you look at 7, if f of x is 7, x could be either 1, because 1 is matched to 7, or 4, because also 4 is matched to 7, or x equals 4. Okay, so you notice that in the first one, there's a guarantee that there is a output for the first input. But and that's what I wrote at the bottom. The function guarantees that there is one output for every input, but it does not guarantee that there is one input for every output. Like we saw in f of x equals 7, I can have more than one input for the 7 as my output. So on the next exercise, I want us to think about if this is a function or not. So example exercise 1 says define f to assign each student at your school a unique ID number. Okay, so if you have all your students in the school and you have all whole numbers, you assign each student then a unique ID. Okay, so is this an example of a function? And use the definition to explain why and why not. So if you answered yes, you are correct, because each student in the school is assigned a unique each student has a unique ID. Okay, so each one of the students gets his own ID number. Okay, so question B says, let's say Hilda has this ID. What does that mean? It means that 350123 is Hilda's ID number. Okay, so question C says write your name and your student using the function notation. So function notation, you put your name and your number. That's how we use function notation. For the second example says, or exercise says, let G assign each student at your school to a grade level. Is this a function or not? If you answered yes, you are right, because each student is assigned to a single grade level. You can have a student be in both 7th and 8th grade. Okay, they're assigned to a specific grade. So B says express your relationship using function notation and state the domain and the range. So if the function G represents all the students in the school have to be assigned a grade level. So the domain are basically all the students enrolled in the school. But when we go to the range, we only have 5, 6, 7, 8. So we only have these 4 grade levels. So now we're going to use a different function. Okay, so it says let H be the function that assigns each student ID to a grade level. So you're going to find a student ID that is assigned to a grade level. So your domain in this case will be of all numbers used as student IDs. Okay. And then the range will be just all 4 grade levels. So to record an ordered pair, it will be X. So I can write down a number. Let's say whatever Hilda's number was, 350123, and I could put that she is in 8th grade. So this C is important because Johnny says this is not a function because every 9th grader, let's say 8th graders, is assigned the same range of value of 9. The range only has 4 numbers, but the domain has a number for every student in our school. Explain why Johnny is incorrect. So you can say that this individual, so this represents a number for one of the students, is assigned to 8th grade. Well, this same number cannot be assigned to a different grade level. It has to be assigned to the 8th grader. because he is in 8th grade. He cannot be both in 7th and 8th grade at the same time.